Okay, good morning. Good morning. You are welcome to today's lecture on BFTBD 253 pharmaceutical calculation. We will continue from where we stopped. As I said from the beginning of this class, that this is just a revision for your certification examination. Question-oriented approach is what we are using. So yesterday, we did answer the question on ratio, proportion, and variation. So today we pick a question from pharmaceutical measurement and see how it goes. We pick a question from pharmaceutical measurement. Okay, the question says, a child weighs 45 pounds. A child weighs 45 pounds and is to receive 2 milligram per kilogram per day of a drug. And is to receive 2 milligram per kilogram per day of a drug, full stop. How much of the drug should the child receive per day? How much of the drug should the child receive per day? Who can solve for us? Any idea? Pounds, LB, 45 pounds. 45 pounds. Okay, 1 pound is 2.2 kg.
2.2 kg. I know what
Where is your book? Where is the farm card book? Where is it? You give me it out. So what is the relationship between pounds and kilograms? So that is, remember we are talking, this topic has to do with pharmaceutical measurement. Now we are talking about the interconversion from metric system, from imperial system to metric system, avoirdupois to metric system.
2.2.
So which is which?
1 pound.
1 pound.
Kg. 2.2 pounds goes to 1 kg.
Good morning. Okay. So 1 kilogram is 2.2 pounds. All right. So what's the answer?
Is it the 40? It's 40.9 actually.
Okay, so how do you get 40.9?
I had to find the relationship between pounds and kilogram, which is 2.2 pounds equals to 1 kg. So how many kg will make up to 45 pounds, which is 20.45. Then that's 44.45 kilograms. So if the child is supposed to take in 2 milligrams per kg, so how many milligrams will it take? For that, that is considering the weight 20 to 20.45 kg. How many milligram would I take? Which is 40.9 or 41 if you approximate it.
A child weighs 45 pounds.
And is to receive 2 milligram per kg per day
Okay.
of a drug. How much of the drug should the child receive per day? Like how much of the drug?
Okay.
Because this is 2 milligram of the drug that 1 kg child will receive. How many kg would this a child that weighs this particular weight will take?
So 2.2 pounds is 1 kilogram. Therefore 45 is what? 20.5 kilogram. 45 kilogram. Okay. So one gram, 1 kilogram is for 2 milligram.
Then 24.45 kilograms is now for.
Okay. Okay. I agree with you. I agree with you. So this is just the interconversion, converting from one system to the other, from imperial to metric system. Now, so this is simple now. It is not right. Okay. It's simple now, Shay.
How to know what that's where she got 2.2.
1 kilogram. What? No, this is a well-known interconversion factor everywhere. That 1 kilogram is equal to 2.2 pounds. This thing will lead you to this will is a kind of bridge between metric, this metric system and this is imperial system. So if you know this thing, there's no question they will ask you that has to do with moving from what as far as weight is concerned. There's no question they will ask you that has to do with this movement that you'll not be able to answer it. Sometimes question may come in kilogram, and they may want you to find the answer in pound. So once you know this, you can easily solve any question. Okay. Let's look at this question. Good morning. In dosage calculation. Let's look at this question in dosage calculation. The question says, are we there? Are we good? Good. The question says, dexamethasone oral solution. Dexamethasone oral solution 0.5 milligram per 5 ml. Five milligram per 5 ml. Dexamethasone oral solution 0.5 milligram per 5 ml. Okay, let me write it. Let me just write it. It's better written down. This is an American system of writing prescription. You see something like this. Dexamethasone It's a prescription anyway. Oral what? Solution. Can you see this marker?
No, you can check the black.
Addressing Mogoda Place and record the
Oh, we should wait to the provost now.
for this school.
Archbishop Shasiri, College of Health, Science and Technology. Mkpoagbo. Welcome. Okay, so look up, please. I'm going back because you say you are not following. That's why I'm going back now. We are given £5. We are told this is the formula. Let's assume that this came from an official book now. BPC, as case may be. This is the formula in BPC. Whether they are doing in large-scale production or they are doing entrepreneurs one in the lab, they need we need a formula. There's a formula. But that formula has a quantity it can produce. The formula has a quantity it can produce, or the amount it can produce. This ingredient here, this quantity of ingredients here, can only produce 1,000 grams of an ointment for us. But we are asked to determine the amount of these ingredients. We need to produce 5 pounds of a hydrophilic ointment, and we converted this 5 pounds to gram and got 2,270 grams. Now, if you compare what we are formulating, the weight of what you are formulating, compare it to the weight of what we have in the words, with the weight of what you have in the formula, what we are produce is far below. Okay, no, we are. Okay, I have 1,000 grams now. 2,200 grams. Are they equal? This one is far higher than this one now. The only thing you can do to be able to produce this one is to enlarge this formula. That you cannot what? So we converted pounds to gram. Now, this can only produce 1,000 grams for us, but we are asked to produce 2,270 grams. So to enlarge the formula, that's where the factor, you need a factor to be able to enlarge it. That means you divide the quantity you want to produce by the quantity of what you have in the official book. It will give you a factor. You use that factor to multiply all the ingredients. And if you do that, you now have a formula, have the quantity that can, if you combine, you can produce this. But remember, in real life scenario, you put into consideration overage. You put into what? Consideration overage. Because if you determine this factor now, we got to 2.27, right? And use exactly 2.27 to multiply all these things here. What you will get, you get the exact weight that will give you 2,270 grams. But by the time you start measuring, weighing these weights, there is what is called loss by transference loss of powder. as you are moving them from the container to the mortar or whatever, you lose some quantity. And even when you try to, after titration or mixing, some will still remain in what you use to mix it. You see that at the end, if you weigh exactly this, if you multiply this whole thing with 2.27 and weigh exactly that, there will be a problem, because at the end you can never in this life produce 2,270 grams. You may end up producing 2,000 grams if possible, because of those losses. So to avoid that, in real life scenario, this is just a calculation, but in real life scenario, you put your overage, and to be able to get that overage, you put the overage should be proportional. You don't put it individually. So to put the overage now, you incorporate it in the factor you want to use to do what? Multiply them. If having gotten this thing to be 2.27, you can decide to make it 3 safe. Just need some space. You may decide in real life, you may start to multiply by what? 3. Then at the end, 4. By the time we have this multiplier effect. By the time you multiply it, it may lead to waste of ingredients. It may lead to waste of, at least 3 is okay. 3 is okay. So when you are done, hello, when you are done, if you multiply, let's assume you multiply. Let's do as if you are doing practically now. You got 2.27, right? You decide to use 3 and multiply this whole thing here by 3. If you multiply everything here by 3 and get values, you now mix the whole thing. After the blend, after titration and blending, you now weigh out the 2,270 grams you are looking. If you mix properly and weigh out 2,270 grams, they will contain that in the actual proportion that they would have, that theoretically multiplying 2 by 2,227 would have given you. To give you the same, they will contain the same amount of these ingredients, because you mixed well. So, but for the purpose of just calculation, you just multiply by 2.27 and get your answer. In measurement, I taught you run away from approximation in pharmacy, because what you are approximating is wrong. These things are not abstract numbers; they are denominate numbers. If you approximate from 4.5 to 5, you are adding excess ingredients. Or it's not abstract number you can just approximate anyhow. That's why we have different accuracies and sensitivities of weighing what balances. So even if it's 1.456, you can still have balance that can still do what? Weigh it. You don't just close your eyes and approximate. If you approximate, maybe you round up or round down. When you are done, you either produce something that has sub-therapeutic effect or even excess. So run away from too much approximation as far as pharmacy is concerned. Not only for oneself, in real life practical calculations. Most of these calculations you do in mathematics, general mathematics, is just abstract. They are just abstract numbers. Just like you are as an engineer or a builder or whatever. Maybe the quantity of the, are you aware that if you go to where civil engineers are building, civil engineers, these things, the cement, quantity of cement you use is measured. Are you aware? Are you aware that they are measured? Not the same. All these people are doing there. ndị amụọrụ na nke ọgajo we one bag we anyhow. If you go to where those are builders, as in those that went to the school to read building, or as in building, as in not just maybe if you see where if you go to their site, all these things are calculated. The same way, if you see a chef, quantity of maggi to put is calculated in proportion to the soup you are cooking. So these things are calculated. So by the time once you have denominated these numbers, run away from what? Approximation. Because if you approximate, you are adding more of that what ingredient you are using in doing whatever you are doing. The same thing applies to what? Formulations. Instead of approximating, look for a weighing balance that can help you to do what? Weigh that quantity. Simple. Or you can even weigh it by aliquot what? Method. And get what I'm looking for. If you don't have access to weighing balance that can help you to weigh that. Okay. So what is the answer to this one? Paraben is what gram? Paraben, methylparaben is what? Propylene sodium lauryl sulfate. Okay. So at the end, if you add everything, it should be able to give you what? This 2,000 what? 270 should be able to give you that. I'll stop here. I'm managing to talk. I'll stop here for today. Tomorrow, next week continue. Any questions so far? Ask. If you have any questions, feel free to ask. Let me answer before I go. If you have any question, ask. BPC is British Pharmaceutical Codex. We did this first year now. You scattered it now that time. No, we have BP, we have BPC. All these things, BPC is when it comes to BP. So in fact, BP and BPC when it comes to pharmaceuticals formulations is BP and what? BPC. When it comes to what? Formulations. But when it comes to as in formulation as in preparing drug product. But when it comes to maybe dispensing clinical aspects, interacting with patient, giving drug to medication to patient, that's where this thing will come into play. BNF and the other ones. I'm coming. Are we there? So I will stop here. Thank you very much. Please study, please. From your reaction, you look as if you have forgotten almost everything we did in our second year. That's the purpose of this revision, so that you can go back again and all right, see you next time.